Hello everyone, welcome to physics class. Let us continue chapter 3, current electricity. Today you are going to learn about limitations of Ohm's law. In the previous classes we have already studied what is the statement of Ohm's law and its equation. Now you are going to study about the drawbacks or disadvantages or limitations of Ohm's law. Before going to study about limitations of Ohm's law, first we have to know what are ohmic devices and non-ohmic devices. Let us concentrate on ohmic devices. So what are ohmic devices? The devices which obey Ohm's law are called ohmic devices. If that device is obeying Ohm's law, what is Ohm's law? What it states? We know that when the potential difference across the ends of the conductor is directly proportional to electric current when temperature and other physical conditions are constant. That means V is directly proportional to I. So if it obeys this condition, then that device we can call it as ohmic device. So let us concentrate on this graph. The graph is between V and I for ohmic material. V indicates voltage or potential difference which is taken along y-axis and electric current I is taken along positive x-axis. So when we draw the graph of V versus I for ohmic material, the graph should be a straight line. So this straight line is passing through the origin. When we can get this linear or straight line? Only when the device obeys Ohm's law. That means, see here, V is directly proportional to I, or we can write V equal to I into R, where R is proportionality constant and it is called resistance. So R equal to, we can write V divided by I. So for different values of V and I, the R value should be constant. You can take any value of V and I, but R is always constant. Then only we can get a straight line. For example, if I am going to take voltage 2 volt and current is 2 ampere, what is the value of resistance? That is 1 ohm. Suppose if I am supplying 5 volt of potential that produces 5 ampere current. So what is the answer? Again we can get 1 ohm. So when the value of resistance is constant for different value of V and I, then we can get a straight line that indicates this device obeys Ohm's law. That is, V is directly proportional to I. That means as the potential difference increases, current also increases, and this resistance we can call it as static resistance. So why we are going to call it as a static resistance? Because here this resistance is only for direct current. This is applicable for DC, and as well as the flow of electron or the flow of current is in a single direction. So when the flow of current is in a single direction, when it is applicable for direct current, then that resistance we are going to call it as static resistance. And the examples of ohmic devices are galvanometer, ammeter and voltmeter. These are the some example for ohmic devices. So what is galvanometer? Galvanometer is used to measure electric current, but here it shows small amount of current or it shows presence of current. And ammeter is a device which is used to measure electric current. Don't get confused with galvanometer and ammeter. Galvanometer is having high resistance, so it shows only small amount of current. Ammeter is having low resistance, so it shows large amount of current. And then voltmeter, it is a device which is used to measure voltage or potential difference. So these are the some example for ohmic devices. Is it clear? So what are ohmic devices? The devices which obey Ohm's law are called ohmic devices, and for ohmic devices when we draw the graph of V versus I, it is always a straight line. Right. Then it is non-ohmic device. So it is exactly opposite to ohmic devices. So what are non-ohmic devices? The devices which do not obey Ohm's law. Then we can call it as non-ohmic devices. Then let us observe the graph. The graph is again between V and I, that is potential difference versus electric current. So for non-ohmic material, we will not get a straight line. Instead of straight line, we will get a curve. So why we are getting a curve here? So when we are getting the graph in terms of curve, that indicates it is not a static resistance. Means the value of R will be different for different value of V and I. For example, see here, V is directly proportional to I, or V equal to IR, R equal to V divided by I. Suppose the value of potential difference is 10 volt and we are getting 5 ampere of current. So what is the value of R? That is 5 ones are 5 twos are 10. So we will get 2 ohm. In the second case, I am going to supply 10 volt potential difference and 2 ampere of current we are getting. So what is the value of resistance? That is 5 ohm. So the value of resistance is different. So we can get a curve when we draw the graph of V and I. That indicates, so this resistance is dynamic resistance. So we are going to call it as dynamic resistance because it is not in a unidirectional. The flow of current is not in a single direction. So we can call it as dynamic resistance, and most of the time this is applicable for AC, that is alternating current. And this resistance value is different for different value of V and I. So we can get a curve instead of straight line. Remember, ohmic devices obey Ohm's law. Non-ohmic devices do not obey Ohm's law. For ohmic devices, we will get a straight line of graph between V and I. But for non-ohmic devices, we can get a curve when we draw the graph between V and I. So in ohmic devices, we can get static resistance, but in non-ohmic devices, we can get dynamic resistance. Is it clear? Then we can observe some example for non-ohmic devices. The first example is semiconductor. What do you mean by semiconductor? Semiconductors, these are the materials which have a conductivity between conductors and non-conductor. That means neither conductor nor insulator. So its conductivity will be between conductors and non-conductors. So we can call it as semiconductor. Then the second example is thermistor. Thermistor is also a type of resistor, and its resistance value is dependent on temperature. As the temperature changes, its resistance value also changes. So we can call it as thermistor. Thermal means heat energy, or it completely depending on temperature. And the third one is diode. Diode is again a semiconductor device, and it is having two terminals. See here, this is the diode. It is having two terminal. One is anode, another one is cathode, that is positive terminal and negative terminal. And typically this diode allows the flow of current in one direction. It allows only in one direction, either forward or reverse. So this is diode. And then come to transistor. Transistor is also semiconductor device, and these transistors are used to amplify the electronic signals. So there we are using transistors. Then next example is vacuum tube. Vacuum tube is a sealed glass tube. It is completely packed here. It is completely sealed, which contains air, or it is completely a vacuum, and it allows the free passage of electric current. So we are going to call it as vacuum tube. And discharge tube. That tube contains charged electrodes and it is filled with a gas in which ionization is induced by electric field. Semiconductor, thermistor, diode, transistor, vacuum tube, discharge tube, these all are non-ohmic devices which do not obey Ohm's law. So whenever you are drawing a graph of V versus I, so it will never be a straight line because it is not following that proportionality statement. So this is all about ohmic devices and non-ohmic devices. Dear students, Ohm's law states that at constant temperature, the potential difference across the ends of the conductor is directly proportional to current flowing through the conductor. That is, V is directly proportional to I. This is the Ohm's law statement. And it is observed that under certain conditions, Ohm's law does not hold true. That Ohm's law does not hold good under certain conditions. So in this class, we will learn various limitations of Ohm's law. So first one is V ceases to be proportional to I. So V means potential difference. Potential difference ceases to be proportional to I. That means V is directly proportional to I. So for the conductors, when we are going to talk about the conductors, so what are conductors? Conductors means we can take a metals which allows the flow of current. Here for the conductors, current increases with increase in voltage. Current increases as the voltage is increased. So that indicates V is directly proportional to I. So this is our statement. So it is expected that the graph should be a straight line. So when V increases, I also increases. That means the graph should be a straight line. You can observe this dotted line here. The graph should be a straight line. At higher values also, this should be a straight line. As we are going to increase voltage at higher value, at a high voltage, that graph should be a straight line that we are expecting from this Ohm's law. However, at high voltages, large current causes heating. See here, when we are going to consider high voltage, at higher voltages, so we will get large amount of current. As the voltage increases, current also increases. So we can get large amount of current. When the large amount of current is produced, with that certain amount of heat will be released. So that heat produces resistance. So that means heating of conductors. Heating of conductors means temperature increases. As temperature increases, collision increases because the atoms or the positive ions which are present in the metal, they will get large number of heat energy and they are activated. They start to vibrate. Because of their vibration, more amount of collision takes place inside the conductor. Because of the collisions, resistance increases. When resistance increases, current decreases. Is it clear? You can observe this flow chart. So according to Ohm's law, we know that V is directly proportional to I. As voltage increases, current also increases, so that we should get a straight line when we are drawing a graph of V versus I. As voltage gone increases at higher voltages, we will get a large amount of current. Because of large current, heating of conductors takes place. That means temperature increases. As the temperature increases, more amount or more number of collision takes place. When collision is more, resistance increases. As resistance increases, current will be less because resistance that opposes the flow of current. So current is decreasing. We are providing high voltage but we are getting less amount of current. So at high voltages, slowly this straight line will be bent. That means we are getting a slight curve at this position. So this indicates at higher voltages or at very small voltages, so V is not directly proportional to I. That is, V and I are not proportional. So this is the first drawback of Ohm's law. Then second point, relation between V and I depends on sign of voltage. So this is in case of semiconductor. We are talking about semiconductors. So when we apply Ohm's law statement for the semiconductors, semiconductor device means we can take a diode here. So as I already told you, diode is a semiconductor device which is having two terminals, positive that is anode and negative is cathode. So here this diode allows the flow of current only in one direction. So that's why relation between V and I depends on sign of voltage. So observe the graph here. If V is the voltage that produces I current in forward direction. So here we consider voltage and electric current along positive X and Y axis. So when we are reversing the directions of voltage, keeping the same magnitude is the same, but we are just reversing the direction. That means we are taking along negative x-axis for potential difference, negative y-axis for electric current. Right? Now what happens when we reverse the direction of voltage, keeping the same magnitude does not produce current of same magnitude. If I am going to reverse that direction, for example, for the positive end of the diode, if it is connected to negative end of the battery, when the direction of voltage is reversed, it will not allow the current to flow in this direction. So we are connecting electric current like this. Now it will not allow the flow of current in opposite direction. So that's why relation between V and I, that is depending on the sign of voltage. Then next drawback is relation between V and I is not unique. That means conduction for materials. For example, I am going to take gallium arsenide. You can observe the graph here. We can notice that for same value of current, there are different values of voltage. See here, the value of current, here it will be same. Right? This point you can observe the value of current is the same for different voltage. So from this graph, we came to know that for same value of current, there are different values of voltage. Just we can take the one example like gallium arsenide. So from this graph, we came to know that relation between V and I is not unique. It will be different for different material. Right? These are the some disadvantages or limitations of Ohm's law. So what are the disadvantages of Ohm's law here? The first point, it is applicable only for conductors at constant temperature. Temperature should be constant, then only V is directly proportional to I. Otherwise, we will get a graph like a curve when we are drawing a graph of V versus I. Second point, it is not applicable for conductors at very low and very high temperatures. when temperature is very low or when temperature is very high, so that the value of resistance changes, that is dynamic resistance we can get at a very low or high temperature. So when the temperature is moderate, then only Ohm's law is valid. Third point, it holds good only for steady current. When there is a steady current or direct current, then only Ohm's law holds good. Otherwise, it will not holds good. That means it holds good only for DC but not for AC. Fourth point, it holds good only if physical conditions remains constant. If all the physical conditions remain constant, then only Ohm's law holds good. For example, you can take a temperature, pressure. So these are the some physical condition. When all these physical conditions are constant, then V is proportional to I. Then fifth point, it is not applicable for semiconductors, diodes, transistors, vacuum tubes, discharge tubes, etc. These all are non-ohmic devices. Right? So for non-ohmic devices, Ohm's law is not applicable. So these are some limitations or some drawbacks of Ohm's law.